This lesson covers installing the Hyper-V role on your server. The server must be a 64-bit server, which is a requirement for Windows Server 2012 anyway, and we require the processor to support hardware-assisted virtualization, which is AMD-V technology for AMD-based processors and Intel VT for Intel. A great way to check this is to use this Core Info utility from the sysinternal site. Once you've downloaded this utility, run it with the -V switch. The -V switch will show you only the virtualization related features. Here it shows me the hypervisor is not present because I've not yet enabled the role, but I can see it supports Intel hardware assisted virtualization because of this asterisk. It does not support extended page tables, which is the Intel secondary level address translation technology. This is not mandatory for Hyper-V, but it is preferred where possible. Secondary level address translation takes care of letting the processor map physical memory to virtual machine memory and removes that burden from the hypervisor, which really improves performance. Additionally, I can see if I enumerate my boot configuration database, I can see currently the hypervisor launch type is actually set to off. In this example, I'm actually running this server with the server with a GUI. I have the graphical interface and the management tools locally. But in your environments, you should always run Hyper-V on server core. You want the minimal amount of extra operating system as possible, because every time you have to patch or reboot the parent partition, i.e. the operating system was actually physically installed on the server, this is acting as a management layer for your virtual machines. The virtual machines do not run on top of Windows Server 2012, they run directly on the hypervisor that's going to be installed. But Windows Server 2012 is managing them. It is providing certain services related to storage and network. So if you have to reboot this parent partition, all the virtual machines will have to reboot as well. Therefore, it's very important I minimize that amount of reboot work by running server core on all my Hyper-V servers. Now, if you cluster your servers together, then virtual machines can move between them with no downtime, so that does minimize the effect of a reboot, but still the best option is to run server core. I could then add the role remotely. I install the role like any other feature. Add roles and features. Next, it's a role based. I select the server. I'm going to install Hyper-V and the management tools. So once again, we could use the install-Windows feature PowerShell commandlet that we've seen in other lessons. I'm going to get some extra configuration options. We're going to create many virtual machines that have virtual storage, virtual memory, virtual processors, but they're also likely going to want to connect to the network to be able to actually communicate with other servers and client devices. During this wizard, it gives you the option to actually create a Hyper-V virtual switch for you. I have a dedicated NIC, this VM NIC. However, I'm not going to make it create it for me automatically. I'm going to create that manually later on. It's possible to configure this machine to support live migrations. Live migration is the ability to move a virtual machine between Hyper-V hosts with no downtime to that virtual machine. It copies its memory, its CPU state, device state, while the VMs is still running, removing any downtime in that guest operating system. And by guest operating system, I mean the operating system running in that virtual machine. I can select the default location where I wish to store my virtual hard disks that make up the virtual machines and the configuration files that make up the virtual machines. I click Next. A reboot is required to add or remove the Hyper-V role. And I'm going to let that complete. That reboot has now completed. The hypervisor would have been enabled. Now it's going to complete the final stages of the configuration in Server Manager. But some changes have now happened to this box. While this is actually launching, if I go back to my command prompt and enumerate my boot configuration database, we now see the hypervisor launch type has been set to auto. This operating system we're running, even though this is the parent partition, this was physically installed on the operating system, is also now running on top of that hypervisor. One way you would actually see this is if this machine had more than 64 logical processors, i.e. maybe had 8 physical processors and each of those processors had 10 cores, and it wasn't using hyperthreading, that would be 80 cores available, 80 logical processors. Windows Server 2012 supports up to 64 virtual CPUs per virtual machine. Well, this parent partition is now running on top of that hypervisor, so it would only be able to see 64 of the processors. This doesn't mean the virtual machines won't be able to access all of the resource. The hypervisor takes care of dividing that. The hypervisor can access hundreds of processors and divide them between the virtual machines. This is simply stating that you might see a difference on that parent partition, but don't worry, the hypervisor is still using all the processors in your server. In fact, Windows Server 2012 Hyper-V supports up to 320 logical processors in your physical box, up to 4 terabytes of memory, and can divide that between all the virtual machines you have in the environment. So Hyper-V is now installed. I can close this. I can launch my Hyper-V Manager, and I can now perform some basic configurations on the server itself. For example, Hyper-V Settings allows me to again see those locations, configure NUMA spanning, which is a consideration when you have multiple processor server motherboards. Each of those processors is typically connected to a bank of memory. That processor can therefore use the memory in that bank that it's directly connected to faster. There's a shorter distance, and that's called a NUMA node. Ideally, we want to be able to pass that information to our virtual machines, so that NUMA topology is passed through to the VMs by the hypervisor. But NUMA spanning means I'll actually allow memory to be allocated to virtual machines that maybe isn't connected to the processors that the virtual machine is using. This may give us a slight degradation in performance, but very slight degradation, but it gives us the most flexibility in terms of making sure I can access all of the resource in my machine. I can configure the amount of live migrations that can run concurrently, but first I actually have to enable it. I can control my storage migrations, the ability to move the storage of a VM without any downtime to the virtual machine, if I'm using Hyper-V Replica, and then how my keyboard is used on virtual machines, my mouse, and just reset back to the defaults. This concludes the lesson on installing Hyper-V.